Alrighty, everyone. So last section, remember Unit 11 is all on volume. Unit 10 was all perimeter and area, so two-dimensional flat shapes. Now we're working with three-dimensional, or remember another word for three-dimensional figures is solids. And we're finding the volume of specific solids. For this section, we're going to focus on prisms and cylinders. And we're going to group these two solids together because prisms and solids both have two parallel and congruent bases. And because they have these two similar properties, they're going to have similar formulas for finding the number of non-overlapping unit cubes. So now we're talking about cubic units that we can fit inside of an object of a given size that will fill the interior. Okay. So area is covering the surface with square units. Volume is filling inside of a figure the number of cubic units. And our formula for volume is volume of a prism and cylinder. It's pretty simple. It's base times height. Okay. We write base now with a capital B because that's just a reminder that it means the area of the base. All right. So for a rectangular prism, the base, remember the bases are the two parallel non-overlapping sides. So base, these are my two bases. So then the formula for the volume of a rectangular prism would be base times height, because the volume of the base of a rectangle, it's just this base and height, or length times width, and then times the height. So now we're going to be multiplying three dimensions, length times width times height for a rectangular prism. For a cube, so I'm going to fix this V. For a cube, the base, height, and the length, the width, and the height, they're all the same length. So for a cube, it's just side times side times side, or side cubed. Okay? And we can use these two formulas to find the volume really of any prism. Triangular prism, rectangular prism. That's all we're going to really do for this section. So let's go ahead and let's do example A and example D together, and then I'll let you pause the video and you can work through B and C on your own. Okay, for A, this is a rectangular prism because the two parallel and congruent bases are rectangles. So our volume would just be 10 times 12 times 8. Length times width times height. And then just multiply them all together, we get 960. And remember, this is the number of cubic units that you can fit inside of this object. So it needs to be centimeters, not squared anymore like area, but centimeters cubed. Right? Okay, for D, remember when we're naming solids, this particular prism we name by the bases. And in this figure, this would be a triangular prism because the two bases, the two parallel and congruent faces, they're triangles. So remember, our formula for volume is still base times height. But if the bases are triangles, we need to remember our formula for the area of a triangle, which is 1/2 base times height times the height of the prism. Okay. We know that the 3 and the 4 are based on our height of the triangle because they meet at 90-degree angles. We talked about this and had a big emphasis on it last unit. So our base and our height of the base are 3 and 4. And then the height of the prism is this length right here. Height. Height is the length that connects the two bases, and that would be 3. So our volume would equal 18 feet cubed. Okay. All right, why don't you guys practice B and C on your own. Pause the video and give them a try. Right, for B, our volume should just be the base area of the base, which is 9 times 4, times the height of 6, gives us a volume of 216 centimeters cubed. For C, this would be a square prism because the two bases, square prism. So the volume would be 5 times 5 for our base, times a height of 10. So the volume of this square prism, 250 meters cubed. Okay. So for a prism, area of the base, for if it's a rectangle or a quadrilateral, it's base times height. And then if it's a triangle, that's your base, 1/2 base times height, and then multiply by the height of the prism. All right, our formula for the volume of a cylinder is very similar because our two bases, these two parallel congruent bases, are circles. And if you remember our area, our formula for the area of a circle, it's pi r squared. So then the formula for the volume of a cylinder would be pi r squared times the height of the cylinder. All right, let's practice that together on letter A, and then you guys can try example B on your own. So the base has a diameter, the two base circles have a diameter of 18. So for volume, pi r squared, remember the diameter is 18, then the radius would be 9. So pi times 9 squared times the height of 14. We are not leaving it in terms of pi, we're rounding to the nearest tenth, so we're going to punch this into our calculator. We're going to punch in 81 pi times 14 to get the number of cubic units that we can fit inside of this cylinder. 81 pi times 14, round to the nearest tenth, 3,562.6 inches cubed. All right. Okay, why don't you guys pause the video, try example B on your own, and I'll put the solution up when you're done. For B, it should be volume equals pi times 3 squared, because 3 is our radius, times a height of 5. 9 pi times 5 gets you 141 meters cubed. Okay. Alrighty. We have not talked about any composite figures yet, but just like finding the area of composite figures, we can find the volume of composite figures where it's made up of multiple solids that we know formulas for. So let's try example A together. Hopefully you're able to see that the two solids we have in this figure would be a rectangular prism at the base that I'm highlighting here in blue. And then on top of the rectangular prism, we have a triangular prism. Okay. So let's go ahead and find the volume of both, and then we can add them together. Let's do the rectangular prism first. Base times height. Remember the base, it's the area of the base, so that would be 8 times 4 times the height of 5. And now let's find the area of the triangular prism. The area of the base, so 1/2 base times height. We know the height of this triangular prism, it's this length right here, h, and we can see that's already given down here at this 4 centimeters, so the height is 4. The tricky part is finding the area of the base of this triangular prism. So I'm going to erase some of these figures and lines because the area of the base is the area of this triangle right here. Okay, and we need to know what this length is, h. Well, if we know that it's an equilateral triangle, 8, 8, and 8, we had a couple examples like this last unit where this forms a 30, 60, 90. Sorry, let me write a little bit smaller here so you guys can see that. This forms a 30, 60, 90 special right triangle, which means this length down here would be 4, and then the length of the height would be 4 times the square root of 3. If you remember the properties in a 30, 60, 90 triangle, the side opposite of 30 is half the hypotenuse. The side opposite of 60 is that short leg times root 3. So for the area of the base, we have 1/2. The base is 8. It's this whole length right here. The height is 4 root 3 times the height of the prism plus the volume of, let's multiply that out, plus the volume of the rectangular prism. 8 times 4 times 5, 160. Okay, and then we can just punch this whole equation into our calculator. Half of 8 is 4, so 4 times 4 root 3 times, so let's get out of our radical, times 4. So we get 160 plus 110.9 when we're rounding, which leaves us with 270.9 centimeters cubed. Remember, composite figures, break it into two solids that we already know the formulas for and then add them together. All right, why don't you guys try example B, pause the video. But remember, this is a cylinder up top and a triangular prism on the bottom. Okay, so for example B, you should have, or I would have, first found the volume of the triangular base, or the triangular prism. Remember, your height is 9, and then the base here is 8 and 6, and those are actually your base and your height because, again, they meet at 90-degree angles. So the volume would equal 8 times 6, don't forget your half, 8 times 6, times the height of 9, and then add the volume of the cylinder, which would be, we need to know the radius. In order to know the radius, we know if this is 6 and 8, this is a right triangle, this is a length of 10 because 6 squared plus 8 squared, Pythagorean theorem, we get 100 equals c squared, and we know that 10 squared gets us 100. So if that's a length of 10, that means our radius is 5. So this should have been pi 5 squared times the height of 5 for our cylinder. And when we add these all together, we get a volume of 608.7 meters cubed. All right. Okay, and the last thing I'd like us to finish with for this section is we've had some examples like this before with area as well, describing the effect of the change on volume when we change some of the dimensions. So let's do letter A together, and you can finish with B, and that'll be the end for this lesson. Remember, first find the volume. First find the volume, and then we can change the dimensions. So if this is a rectangular prism, area of the base, 12 times 4, times the height of the prism, gives us a volume of 384 feet cubed. Now we're going to multiply all of the dimensions by 1/4. So 8 times 1/4, you can just use your calculator if you need to. Just leave this with 2. 4 times 1/4 is just 1. 12 times 1/4 is 3. So we get a volume of 3 times 2 times 1, which is 6. And then remember, you want to compare the two volumes. And the way I've showed you how to do this is take the new volume, divide by the previous volume, it'll tell you how that changed. So 6 divided by 384 gives us this long decimal here. Let's keep it as a fraction, 1/64. So we would say volume is multiplied by 1/64. And hopefully you guys notice that 1/64 is just 1/4 cubed because volume is number of cubic units. Remember when we changed both dimensions for area, it was the area squared. Well, now the volume would just change by it being cubed. Or if we were multiplying, in this case letter B, if we were tripling, it would be that number cubed. So why don't you guys try B, find the volume of the cylinder, then triple the dimensions, find the new volume, and compare the two. You can pause the video and work through this, and I'll put the solutions up when you're done. Okay, so our original volume would have been 28 pi. After tripling our units, our new volume would be, well, we would have pi times 6 squared, because 2 tripled is 6. And then a height of 21, because 7 tripled is 21. So our new volume is 756 pi. And before we compare the two, 756 pi over 28 pi, hopefully we can just guess how the volume is going to change if the dimensions are tripled. We talked about this on the previous problem. If the dimensions are tripled, that's multiplying by 3. So then the volume is going to change by 3 cubed, which is 27. 3 times 3 times 3. And let's just check to make sure that's what we get when we compare the two. 756 pi divided by 28 pi, we get 27. So we would say volume is multiplied by 27. All right. So remember, for these problems, when you describe the effect of the change on volume, your answer should be, how is the volume changing? It's being multiplied by what ratio? All right, two solids that we're focusing on for this section on finding volume: cylinders and prisms. And next lesson, which we will work on Friday, will be our cones and our pyramids. You guys can start working on the homework. If you have questions, I'll answer them during office hours.